Hello and welcome to the tutorial video for Acadec Math Focus Quiz 13 through 14. Parallel and perpendicular lines, easy part, and properties of quadrilaterals in the XY coordinate plane. Not going to type all that out. That is also, I feel, easy, but it is very tedious. When you take these tests, I would recommend that you allot as much time as possible to the second test because it's not hard, I feel, but it is very tedious. I am going to try and get these videos out in the future. Wednesday night. This should be up by like Thursday at 6:30 ish. I was working on it last night and I got literal food poisoning. So just want y'all to know that hopefully in the future these will be available earlier so that you can watch them the day before. But yeah, I was pretty incapacitated until like 3 today. So I guess semi apologies for that. It's not required, but I would like to get these out to y'all sooner. Okay, so first quiz. This is pretty easy. Parallel lines have the same slope. All right, where all of these problems are talking about points in the coordinate plane. It's not just theoretical things. It's numbers they put on the graph, and then you have to figure that out. You don't have pictures. You got to kind of draw your own if you need them. Very simple. Parallel lines, same slope. They'll never touch. Perpendicular lines have negative reciprocal slopes. And what that means, say if you have a slope of 3 on one line, then the perpendicular line, any perpendicular line to that one, will have a slope of, you flip it, so 1/3, and you also have to negate it. So negative 1/3. These two slopes are perpendicular. And perhaps a better illustrative example, oh well. A line perpendicular to a line with a slope of negative 2/5 would be positive 5/2. Because you have flipped it and then you also negate it. In this case, that cancels out the previous negative value. Okay, get right into it. Let A is 5, 3, and B, 7, 9 be two given points. Find the slope of a line perpendicular to AB. So all we're doing is finding this slope and then giving the perpendicular slope to it. Now, for both of these quizzes, I'm going to recommend that right out to the next to the question, you draw yourself a little coordinate plane, and you sketch in your points. And especially on the second test, this is going to help you out a lot because it's just very tedious, and you can eliminate a lot of answer choices right away. Because normally this would have some answer choices. So 5, 3, 5, 3, we're just eyeballing, and 7, 9. The only thing about this is you want to keep it all like relative, I suppose. So, and label them as you go. 5, 3, 7, 9. Now we're going to find this slope, and it doesn't matter which ones we choose first. So I'm going to go with y and y, this being y1. So 3 minus 9 over, and then 5 minus 7. Just got to make sure that you keep them in the same order. So 3 is over the 5 in this case. And this is going to give us negative 6 over negative 2, which is 3. Positive 3 is this slope, which means the slope of a line perpendicular to this one is negative 1/3. So that would be your answer. This is the simplest type of problem for perpendicular lines you can get. The process is the exact same for, like, if it said give the slope of a line parallel to this one, it would just be 3. You would just find this slope, and the parallel line would be the same. It would just be located somewhere else. Different y-intercept, I guess. Okay, this is a more common type of problem that you'll get with this. And I'm going to sketch these points out, except for this one, because we are looking for some value of g so that the line AB is parallel to the line PQ. So I'm going to sketch a little bit. And this isn't strictly necessary. It's just, it always helps you keep track of what you're looking at. I find that all these random numbers just being thrown around everywhere purely as numbers is very difficult to keep track of. So this really helps know what you're doing. So negative 4g we're going to leave alone for now. B26 is going to be like there-ish. B, and that will be 2, 6. It's important to label them so that you can use this picture for your math. And then our PQ line, we go negative 3, negative 2, about right there, and 9, 6. So, like I was saying, you want to keep them relative. So because these are both at a y value of 6, and I'm going to relabel this up there so it's less confusing. You want it to look pretty much at the same y value, at the same vertical height as this other one we drew. And so this is PQ. And we want to find that slope and then find some point on negative 4g. So it's probably going to be about like right here-ish, right? And that's why this drawing helps you. If you got something like way over here somehow, I don't know, like really high up, you would know, for G, you would know that probably not correct. Maybe look at it again. Unless it said perpendicular, then you would know that that's probably correct. So what we want to do here is first, just because I keep saying you're supposed to do it, we're going to label all these. Negative 3, negative 2. And this is a bigger deal, the labeling on the second quiz, because there's a lot to keep track of. You'll see that. So we're looking for negative 4. We're looking for G. So finding this slope, I'll choose this as my first coordinates. 6 for a y1. 6 minus negative 2, so plus 2, over 9 minus negative 3, so plus 3. That's going to equal 8 over 12. And then when you reduce that, divide both by 4, you're going to get 2/3. All right, so that's the slope. So we need to find some G that gives us that same slope. So we'll take 6 minus G. Oops. G. My brain just forgot how to write a G for a second there. And 2 plus 4. Okay, because we're subtracting negative 4. And this is going to evaluate to 6, right? And if we're going for 2/3, and this is 6, then this needs to be 4, right? This needs to be 4 over 6 to simplify to 2 over 3. So G needs to be 2. You could do the actual algebra for this. You could even throw it in a num solve. That's kind of overkill because we can see the ratio here. So G equals 2. And if we look, that kind of looks like our sketch approximation, right? Negative 4, 2 looks about right. So that helps us know, okay, we probably got it right. Especially if you have answer choices and you see some that are really high up, you could be like, okay, even if you can't figure out the problem, you can eliminate B and D or whatever. That's why drawing the sketches help. This is very similar to the other problem. Find the value of th for which the points negative 4, 0, negative 2, and 8, 2 are collinear. Sometimes for these, I just do random alt codes. I don't know if any of y'all know what those are. You just hold down Alt and hit random numbers, and it pops up really random stuff, like a lot of Chinese caricatures and whatnot. I don't know what this is from. Some language. I get tired of just using letters. Find the value of for which points these are collinear. So we're going to draw our points, and collinear just means they're all on the same line. So essentially, this works the same as a problem where you're looking for parallel lines. It's very much like the last problem. So 0, negative 2 is right here for B. 0, negative 2. 8, 2 is here. You know, approximately. It's all relative. And negative 4 something. Right? And we can see that it's going to be somewhere like around here. So it's going to be less than negative 2, but not like by a ton. And that's why this sketch can help you out. Because if you had something like negative 18 over here, you'd go, okay, that's a little too crazy. So anyways, we're going to find the slope between these two lines. And then the slope between this point and either of these, you can choose, needs to be the same as the slope between these two. That would make them collinear. So we'll take this one and we'll go 2 minus negative 2, so plus 2, over 8 minus 0. So this is just 4 over 8, or 1/2, right? So then we want to take this, and we'll use 8 2, because I think it, less negative. It doesn't matter. You can choose either. And 2 minus, I'm going to say C here, because I can't do that, over 8 minus negative 4, so plus 4, needs to equal 1/2. So this is going to equal 12. So that top half needs to equal 6, right? So this needs to equal 1/2. This equals 12. So this being 12, we know this has to equal 6. So 2 minus some number equals 6. It's going to be negative 4. You can also do the algebra for it. Wow. Equals negative 4. And if we look, negative 4 looks about right. The algebra for this is you multiply both sides by 12, and then you would get 12 over 2 equals 2 minus C. This turns to 6. 2 minus C equals 6. It's the same process. Do the algebra however you can consistently do it. But that's how you solve this problem. I added the coordinate grid here just to illustrate a concept. You don't even really need to draw a picture for this. Find the equation of a line which is parallel to the x-axis. And I just wanted to be able to show that this is the x-axis, and any line parallel to that is going to be a y equals some constant, right? So like y equals 3 would be right here, and it's parallel to the x-axis. So this one is saying that it is parallel to it, and it passes through 7, negative 8. So if that y value is negative 8, and we have to have a y equals something equation, then our equation here, it's probably negative 8, I don't know. I can't count very well on the screen. Our equation is going to be y equals negative 8. And this is not, it's not misleading, but every single x value, so from negative infinity to infinity, negative 8 is on that line. And if conversely they said it's parallel to the x-axis and passing through this point, it would be x equals, not x-axis, y-axis. I don't know what I just said. X equals 7. And then that point would be on it. It would be right here, up and down forever. So important to understand what that parallel to the x or y axis means and what those equations look like. Okay, so this looks like a lot, and it kind of is and it kind of isn't. There's just it's the normal properties of quadrilaterals that you'd be used to, except for you have to find those things out using like coordinate plane math, so slopes and distances and such. Mostly slopes. You don't want to mess with distances as much as you can. That being said, drawing the little sketches really helps. All right. So equal side lengths of these are all quadrilaterals. I included this because it's in your math resource. This is just kind of a paraphrasing of it. Equal side lengths is a rhombus or a square, right? Those are the only two things that have equal side lengths in our quadrilaterals. A rhombus is just a square that you've kind of squished a little bit. So it's like a diamond with equal side lengths. Okay? So if you have a quadrilateral with equal side lengths, you have to determine whether it's a rhombus or a square, and you do that by checking if two lines, so this one and this one, or this one and this one, if they're perpendicular. If they are, then it would be a square. If they're not, it's a rhombus, assuming they have equal side lengths. So it's just a lot of process of elimination, because generally it's fastest to check the slopes, okay? So if you have 4 points, usually, say this is on a coordinate plane anywhere, you want to check this slope to this slope, and this slope to this slope. because if those are all parallel, then it can be any of these things, but it cannot be a kite. And then from there, that's just like the quickest way to definitively get rid of so many things, because if these are not, so this is parallel and these are parallel, I think that's the way you can say that. I'm not really sure. Oh, no, it's like little arrows. Whatever. I don't recall. Then if they're not both parallel, say just one of them is, it's probably a trapezoid. Say, and that's not on here because I don't think it's even on the quiz, but you know what a trapezoid looks like. If none of them are parallel, right, then it's going to be probably just be a kite. It helps you get rid of the most the quickest. And if they are parallel, then you want to check the angles, or not the angles, but the relative slopes of the diagonals, like this. Because if the diagonals are perpendicular, right, so if this slope is the negative reciprocal of this slope, then it has to be a rhombus, square, or kite. It cannot be a rectangle or a parallelogram. A parallelogram technically encompasses everything except a kite here, but that is the least specific one. So if it had two pairs of parallel sides and none of these other properties, it's a parallelogram. If it has no parallel lines and it's not a kite and it's not yada yada yada, it's just a quadrilateral. That is an answer choice on these. If you cannot find any properties that are unique or more special, like if they're just kind of four random dots. But yeah, you want to check the slopes first, and then check the diagonals, and then if you have to, check the lengths. But you can usually do elimination, and you'll only be left with one or two left. And based on a little sketch you do, you should be able to tell, because otherwise this is super time consuming. You have to calculate 1, 2, 3, 4, 5, 6 slopes, and then maybe do distance formula for every single question. So efficiency on these is a big deal. Oh, I meant to animate these all in order, so I guess ignore this for now. I'm tired, guys. I did not sleep much. I was sick. The vertices of a quadrilateral are A, B, C, and D. And for this one, I just took it straight from the math resource. Again, I'm tired. There's some that are more unique in a second, where I'll show you how to actually sketch them. But this is precisely what it would look like, right? So immediately, we can be like, okay, that's not a square, and that's not a rectangle, because these angles are not right angles. And that's something you might not be able to trust based on your own sketch, right? Because I might sketch these like all sorts of wacky, and then only kind of know which coordinates they are in relative to each other. And this, my own rendition of it, I can't necessarily say that they aren't 90 degrees, but you could at least kind of get a guess for it. So we have to check the slopes. The slope of AB is 4 over 11, and the slope of CD is also 4 over 11, so they are parallel. And then the same for AC and BD. This math is already done here. You can see how this could get tedious fast. I'm going to show you in a second. I just wanted to get through it real quick here. Since the opposite sides of the quadrilateral are parallel, it is a parallelogram. And we know because none of these slopes are perpendicular to each other. So if this was 4, 11, and this was negative 11 over 4, then we would be like, okay, it's a rectangle or a square, because they would have a 90-degree angle right here, but they don't. So we can eliminate those two options, square and rectangle, were they to be answer choices. But the last thing it could still be, they have two parallel sides. It could be a rhombus. And this is easier to do when you have the answer choices rather than like memorizing all of this. I think you can remember the specific properties. Once you're given a list, you can kind of just look at them and think about it. And I'll show you that. So to check the rhombus, we need to check the lengths. Because if the lengths are all the same, then it is a rhombus, which is just a special parallelogram, just like a square and a rectangle. However, you don't need to check all the sides. These opposite sides are going to be the same length, and so are these opposite sides. So you want to check the two sides connected to some corner. So I'm going to choose BD and CD, and I think the easiest way to do this, and a sketch does help you with this, is not to go pull out the distance formula, but instead to see, okay, 8, 8, to get to 21, so we're going to draw a little triangle. To get to 21 this way from 8, we're going up 13. And to go from 8 down to 4, we're going down 4. We don't care about the fact we're going down. We're just trying to get the two side lengths of our right triangle for the distance formula. And then same thing here. We're going 10 to 21. This is just the other leg. And 10 to 21 is 11. And to go from 0 to 4 is 4. So because these two side lengths are 4 and this is 13 and 11, we can tell that these lengths are not going to be the same. If we did the math, if these were all unique numbers, you would probably need to check just to make sure, because they could be the same. But we know because there's 4 and 4, 13, 11, they can't be the same. So it is a parallelogram only, not a rhombus. You can see every single question is like this exact same thing. It's literally just give you 4 points and then what is it? So you want to draw your sketch and get kind of quick with it, which I'll do that here. And I'm not the best with this tablet. On paper, you could probably get a little bit better than this. Maybe you can have like a straight edge of some kind. I don't know. You can't. You might be able to on the actual competition test. I don't remember. I never did. Maybe you can though, actually, but who can say? Mr. Lane can ask. The vertices are D, E, F, and G. Our D is -6, -5, so like about right here. Our E is 8, 7, so over here-ish. F is 12, 1, so like way over here. And G is 16, 6, so way over here, like that. All right? Now, what's useful about drawing this sketch, obviously these are not accurate. And like I said a billion times, important to label these. So 8, 7, 12, 1, and 16, 6. All right? But we can tell, even based on this like terribly rough sketch, that this is not a square. Everything's a quadrilateral, so if we can't prove any of these other ones, that's the answer. But it's definitely not a square, and if rectangle was on there, it's not a rectangle, it's not a rhombus, because this is so drastically out there. So drawing this sketch can help you immediately to start eliminating. So let's find these slopes of this line and this one. Okay? Because if those are parallel, then we need to check the other ones to see if it's a parallelogram. But if they're not, then we already know it isn't. So it can't be a parallelogram. Because that needs two sets of parallel sides. And if trapezoid was an option here, then we would need to check the other ones as well, but it's not, so we don't. So 8, 7 to 16, 6. We're going up 1 over 8. Or no. I see this sketch. I could edit that out and start over, but these are mistakes that legitimately I, and thus probably others, will make. I was saying everything is relative. 16, 6 is like right here. So we want to see if these two lines are parallel. And now that I've put that in the right place, you can kind of see that, no, they aren't. This one's a negative slope and this one's a positive one. So even just based on that, legitimately, this going up from -5 to 1 and this going down from 7 to 6, these are not parallel. Because this is positive and that's negative. You don't even have to calculate it. So we can scratch that out. So now we need to find out if it's a kite. And the way to do that is to find out if these diagonal slopes are perpendicular. Because if they're perfectly perpendicular, so this is a right angle, then this is a kite regardless of how long these sides are. You don't even have to check that. This is what you're looking for. If these sides were parallel, then you'd have to check this to see if it's a square and a kite and yada yada versus like a rectangle. But we don't have to. We've already eliminated so many things. So our slope from 8, 7 to 12, 1 is 7 minus 1 over 8 minus 12 equals 6 over negative 4 equals negative 3/2. So then we'll check this one, and if it is positive 2/3, so the negative reciprocal of this, then it is perpendicular, so we'll choose kite. Negative 6, oops, that's on the bottom. Negative 5 minus 16. 16, what is wrong with me? Negative 5 minus, again, I'm so sleep deprived. Horrible night. Negative 6 minus 16. And this is going to equal negative 11 over negative 22. And we can immediately see, we can reduce this down to positive 1/2, which is not the negative reciprocal of this. So this is not a kite either. It's a plain quadrilateral. Just 4 random points. They don't have any special properties. And that's the process for doing all these questions. Let's look at this one. Last one. These are all the exact same type of questions. So I'm just trying to cover some of the bases here, but mostly you just have to practice. You just have to figure it out. Let's draw our vertices. We have negative 2, negative 4. More like right here. Negative 2, negative 4. 3, negative 1. So like right there-ish. 4, 2. 4, 2. Right there-ish. And 1, 1. So this kind of looks similar to our last one, which could have been a kite, right? You can't really tell based on your freehand sketch or my freehand sketch. Maybe you're fantastically accurate. I don't know. You could do some really crazy stuff where at the top of the test you draw an actual coordinate plane and then you just erase every time and use it again and again. Don't think that would work out, but, you know, experiment. Go for it. Anyways, we can see that this is probably not a rhombus just because this side length and this side length are going to be a lot longer than these two, just based on the relative places. And trusting your sketch and sketching kind of as accurately as you can will help you do that to get through these quickly. So I know it's not a rhombus. All right. Next, we just want to check the slopes. So we're going to check this one and this one. And like, they don't look parallel, but that's just because of my sketch. They very well could be. So going from 1, 1 to 4, 2, and you don't even have to use the equation for this really. We can see that our change in y is positive 1, and our change in x is positive 3. So the slope is 1/3, because slope is change in y over change in x. So those closer ones that are really quick to look at, you can just see we're going from 1 to 2, so positive 1, and we're going from 1 to 4, so positive 3. And we'll do the same for this. You can do the same thing. We're going from negative 4 to negative 1, so that's a positive 3 change, and from negative 2 to 3, right? So that is a positive 5 change, and that is not the same slope. So these things are not parallel, all right? So we can immediately scratch out parallelogram and rectangle. So now we're just left, and we just really need to check if this is a kite. And to do that, we check if the diagonals are perpendicular, right? So from 1, 1 to 3, negative 1, that slope, we're going down 2 from 1 to negative 1, so negative 2 over, we're going over positive 2. So the slope is negative 1, which means if this slope is positive 1, which is the negative 1 over 1 is just 1, and then we negate it, it'll turn this into positive 1. If this slope is 1, then it is a kite, because these are perpendicular. So negative 4 to 2 is positive 6 over negative 2 to 4 is also positive 6. So this does equal 1. So these are perpendicular, and the answer is that it is a kite. This is, I really spent, like, last night before I discovered I had food poisoning. I spent literally like an hour trying to figure out the quickest way to do these problems, because there is no quicker way than this. It's really tedious. Not the biggest fan of it. I don't ever recall doing these types of problems specifically. I think that might have been... It doesn't matter. I never did them. I don't think there's a quicker way to do it. The calculator has lots of functions beyond writing an actual Python script, which will get you disqualified. I couldn't really find out any way using any of the different pages to do this any quicker than just drawing it and doing all the math yourself. It takes longer to input to special functions and stuff. So best of luck. That's all I got for you.